Okay, today we're looking at the inequalities in two triangles. Main thing, or the first thing that we're going to look at, is the hinge theorem. Now, the hinge theorem deals with triangles. Let me get a color ink here. Deals with triangles when you have segments congruent, as we have right here. Then we have segments congruent right here. So we have two pairs of segments. And the hinge theorem says that if we have two pairs of congruent segments, then this angle in between them, and we kind of see why it's a hinge. We have those two sides and the angle kind of acts as the hinge. If angle A is larger than angle F, then even though we don't know the length of BC, we know that BC is going to be longer than GH because this angle is greater than this angle. So an example here with this hinge theorem, we're going to say if AB is congruent, if segment AB is congruent to segment FG, and segment AC is congruent to FH, which these were the angles that or segments that we marked as congruent, or that were already marked as congruent, then I'm sorry, not yet then. So if those two segments are congruent and angle A is greater than angle F, so we have two pairs of segments congruent. A is greater than F, then segment BC is going to be greater than segment GH. Okay. Don't let all that confuse you. It's just saying angle A is the larger of the two angles, so the segment opposite A is going to be greater than the segment opposite F. Now the converse of that says, same scenario, if AB is congruent to FG and AC is congruent to FH, which those are already pre-marked. Now in this case, instead of saying that the angles are longer, if we were to say that segment BC was greater than segment GH, again talking about these two angles, if BC was greater than GH, then we would make the statement that angle A is greater than angle F. So it's the flip-flop. The hinge theorem originally said that if angle A is bigger than F, then BC is bigger than GH. The converse says, well, if BC is bigger than GH, then angle A is bigger than angle F. Okay, so let's look at that in action on a couple of these problems. So we've got these two triangles. Now remember, they have to have two congruent sides. Well, we have this segment congruent to this segment, but don't they share this segment right here? So they are congruent. Now remember, this is kind of twisted. If we were to redraw these triangles, what would this be? D, A, B, and BCD. BCD had 5 here. This was 5.5. We said this congruent to this, and then these two were congruent. So what this is saying is, notice that segment AD is longer than segment BC. That means angle B is going to be larger than angle D. Now we have to label this, since our picture it looks like this and we don't know what AB and angle B is and angle D is. We're going to say that we have 5.5 is opposite this angle, which is angle ABD. It's greater than, this is 5, so it's greater than that angle, which is angle BDC. Okay, let's look at another example here. So same situation. We have this segment which they share. We have 6.1 here, we have 7.2. 7.2 is larger than 6.1, which means this angle right here, angle KML, is larger than this angle right here, which is angle JKM. This angle right here. Okay? So really, it's similar to what we did yesterday. The segment that's larger is opposite the larger angle. The angle that's larger is opposite the longer segment. Now, the only difference is we have to remember these two triangles, we have to have two pairs of congruent segments. Okay, now let's look at one more thing. This problem, we've got a diagram, and we're not going to look at the proof today, so just we can ignore that right there. So all we're looking at is we're going to find the range now. So we have two triangles, and the two triangles have this congruent segment. They also share this side, so those are congruent segments. So we're looking at these two angles, 141 and this right here. Well, they are opposite the segments 18 and 16, which means the one opposite 18 is going to be the one is larger than the one opposite 16. 141 is opposite 18, so that's greater than 9a plus 15. And now we just solve for a and are left with an inequality. And when we do that, we get an answer of 14 is greater than a. Well, a could not be anything because we cannot have an angle measure less than 0. So what we have to do is we have to find out what a has to be greater than. So we set 9a plus 15 as greater than 0. It has to have a measure greater than 0. We can't have a negative angle measure. So we're going to subtract 15. 9a is greater than negative 15. Divide by 9. And a is greater than, we'll simplify that, negative 5/3. So my answer is going to be a is greater than negative 5/3, but less than 14. And that would have to be the range for my problem. Okay, these are all the notes. Let's look at some examples from our homework. Okay, on numbers 1, 2, and 3, we are looking at those two triangles and trying to determine which either segment or angle is larger. Again, we're going to remember to look for whatever its opposite. Now we have congruent segments. For instance, these are both 2. Actually, let me zoom in here. Let me erase that. No. We have this segment congruent to this segment because they're both 2. This is 5.5 and this is 5.5. And we're looking at the measures of K and M. Well, K is opposite the segment LJ. M is opposite the segment LN. Which of those two segments is longer? LN is definitely longer, which means angle M is the larger of the two. So the measure of angle K is less than the measure of angle M. And you'll do the same thing for number 2 and 3. Now number 4 and 7, we'll talk about this. It's a similar situation. Actually, let's zoom in on that one too. But this time we're finding the range here. We've got congruent segments. I've got this length of 45. I've got this length of 54. Which one is larger? Well, the 54 is, which means angle 153 is greater than the other angle, which is 3x minus 21. You end up with an inequality there. Now when you do that, we remember that the smaller angle, which was opposite 45, has to be greater than 0. So we're going to write another inequality of 3x minus 21 greater than 0. When I do that, it's going to leave me with x being greater than something and x being less than something. And that's what you'll do on 5, 6, and 7. Okay? Number 1, I'll let you figure. And then we have 2, 4, and 5 on the back, and I think that you should be fine. Hopefully that helps with the assignment.